Happy Friday. Okay, today I'm going to go into my first distributed cloud piece. And up until this point, I've talked a little bit about like reusable items in distributed cloud and I think the Terraform provider. But this particular one, this week I had a colleague of mine that was asking about how I would manage customer edges in distributed cloud. And I'm going to go over that right now. So, first of all, let's talk a little bit about where a customer edge lives. I'm going to switch over. If we look at the landing for the repo, what you see right here is generally what the lab looks like. Now, these stacks are regional edges inside the F5 ADN, right, the edge. This other yellow one is what's called a customer edge. Now, there's many different kinds of customer edges. I think there's 6. However, the one that I'm going to deploy and talk about would most commonly be used as a reverse proxy. There's also forward proxies, there's combo stacks where you could host things in them like applications. So there's like 6 different versions, multi-NIC ones. But the one I'm going to deploy is most commonly used for the networking and then also the proxy services. So my colleague had reached out and said, hey, I like your videos, but I really want you to explore managing a CE. So when I instantiate a CE, I'm going to build this in, right? And it's going to allow me to access services behind the customer edge from either the customer edge, another customer edge, or the regional edges at the edge of the F5 network. Now, there are many different use cases for why you would choose those things. East-west, availability of applications, north-south availability, forward proxy. But I'm going to deploy a simple set, and I'm going to walk through the Terraform on how to do that. And then I'll go into the console and you can actually see how I would manage it too. Because his real question was what happens in the event of a problem of a CE or in management of those. What does Terraform look like? Like how do I day 2 operationalize these customer edges? Now I get that they provide a ton of services and I really needed this video to start to talk about those things. So this is the customer edge with F5 Distributed Cloud. Now, over here on the left-hand side, I'm going to go into Distributed Cloud. And this is going to be infrastructure. So this is one of the first infrastructure sets that we've seen. Infrastructure, and then this is all Terraform. So Distributed Cloud does not have an Ansible, let's say, module or resource at this point. Maybe in the future, but right now it's all Terraform. So it's kind of just defaulting to the Terraform pathing. And then in here are some configuration sets. Now, in order to interact with Distributed Cloud, I actually, and where I'm going to land the customer edge, I actually need a couple different credentials. I need one credential that's going to let me talk to Distributed Cloud, and that's an API credential. You'd go generate that from the Volterra or Distributed Cloud console. Then I also need a service principal from whichever cloud I'm going to land it in, right? In the case of having Distributed Cloud build it for me. So I also have a service principal created in under my Azure tenant, right? And that allows me to talk to the Terraform provider for Distributed Cloud, and then that's going to instantiate the configuration in Azure. So the first part here is I'm going to look at a couple of these. I have some managed Kubernetes, some virtual Kubernetes. All of those are really fun things that I'll talk about in another video. The provider like normal. And then I've got these 2 different styles of clusters. The cluster that I'm going to work on is this one. If you're curious, the other cluster is that Kubernetes stack. So F5 does have a managed Kubernetes and I can run applications directly in the CEs also. This just means that it has a few more resources and also is expected to jump into a Kubernetes management. So we're going to talk about this one. Working my way down, I turn up and turn these things down pretty often. I actually leave this out of the lab running all the time because it is infrastructure and that has a cost attributed to it. So I only turn it on like when my friend Ed asks me to talk about how I'd manage these things. So I do use a random string so that I don't step on top of a deployment that I've actually used before or maybe another colleague of mine. The next part is this is a Volterra Azure VNet site. So sites are organized as a location of resources that I want to access. And a site itself can have a number of CEs in it. And mine is going to have 3. The reason for that is a quorum, right? There's not active standby. They're all active. So there's got to be 3 of them. So this is an Azure site. It's going to ask me for a few things. This first part I thought was pretty informational. These are labels that exist inside XC. So if I'm just going in there and I want to look for things, I can sort by those labels, right? These are tags for Azure. If you happen to have an account in Azure that has like Azure security policies or Azure policies where they will delete your stuff if you don't have tags correctly written down, this would be something that you may want. So these tags will be passed all the way into Azure, and it's going to put something like my email address, the resource type, which I say dev or prod, and then like what kind of the product it is. Now, if you've already deployed a CE before, this flag is no longer optional. Even in the documentation, it says that the SSH key is optional. It is not. Now, should you ever log into the CEs? Probably not. You can instantiate developer tools. You can instantiate like command line tools directly from the console without having to go into the CEs ever. But it is no longer optional to put an SSH key on those. There is a hard requirement for now. So I have an SSH key, right? Because I have to meet that. The machine type, you can choose different types. I just chose the standard one, a DS3v2 or a D3v2. Different sizes would give you more compute power, et cetera, for things like the managed ones. Where it's going to go, the resource group that it's going to land in. Now, this will create a resource group. You can alternatively place it into a resource group, but I would not recommend that. I feel like these resources are meant to be their own entity. For one, because it's a lot easier to maintain in code. And also visually in the Azure portal, it's a lot easier to maintain. And I'll actually open up a portal tab while we're waiting. Not really waiting, but while we're clicking around in here. That way you can see what I'm talking about. Okay, so the next part is log streaming. You can stream logs directly from the instance, or you can use the analytics that exist in the console and harvest them out of there. Pretty self-explanatory. No worker nodes means that this deployment is going to be a 3-node cluster and only going to be used for traffic, let's say networking traffic and proxy traffic. If this is going to be one of the Kubernetes clusters, then I may want additional worker nodes, right? 3 master nodes, a bunch of worker nodes, right? Up to, I don't even know, 200 or something like that. So I could have additional worker nodes for holding applications in it. Mine's not going to be that style of deployment, so I'm leaving it there. Default block services, which essentially open ports on the instances themselves. You shouldn't need to log into them, but you do have to have some open for communication. Azure credentials. So now this is that thing I was referring to. I need an Azure credential to be able to build the resources in Azure via the distributed cloud console or via, in this case, Terraform. Latin long, this is super critical. If you put in a Latin long, those that determines which 2 closest regional edges for management, right, or data plane connectivity, the CEs or clusters of CEs are going to talk to. So if you really wanted this thing on the West Coast, but you put a lat long in for Australia, your box is going to live in the West Coast and try to talk to the Australian REs, right? And that's a long backhaul across the globe. So make sure that those 2 things are configured correctly. As I mentioned earlier, there are many different kinds of CE deployments. Mine is an ingress gateway. So in this case, I'm expecting most of my traffic to ingress in, right, to allow somebody externally to talk to a resource internally. Other ones include the stack that I was talking about earlier, right? There's also an ingress egress, so a multi-stack. These are just variants of those, right? And then the ingress gateway that I talked about. So these are multi-NICs, these are single NICs, where this is a single NIC, this is a single NIC. I don't actually know what the _AR stands for. Maybe it's something I just haven't seen yet. A little bit funky in Terraform is the array, which you would expect, but in this case, it's just additional sections. So in this case, my deployment is going to be in 3 AZs in my Azure resource group, AZ1, AZ2, AZ3. Each one is going to have 80 gigs of disk space. It's going to exist in a resource group, right? And then it's going to be attached to a certain subnet. So this is my building of the 3 units. Down below, I get past that. I'm going to just specify which kind of enhancement mode I want. This one's set up for a reverse proxy, so layer 7. You can also, if this is going to be a layer 4, like a TCP UDP style deployment, you can set it up for layer 4 enhancement, giving you some more line rate speed versus compute power. So you get a choice. The VNet that it's going to land in, right? Down in here, I leave offline survivability mode set to true, and that lets my instances hold logs for up to 7 days if for some reason the public cloud connectivity between the CE and our infrastructure ever went offline. Lifecycle changes, because XE does add labels, Terraform doesn't really love that because it wants to remove those, right? Because it wants to own all the resources. So I have it ignore labels just because that way XE can actually control some of their own labels. This last one, when a device comes online as a CE, it comes online, it calls home, and then it waits for you. And it says, okay, I'm new, click this button to allow me to be added to your account. Now, you may want that step, but programmatically, I don't want that step. So this is another resource that says basically apply the name of the site that I just created after the site's been created. That way it comes online, it's applied into my account, and then it just immediately starts its upgrade process and then starts hosting services or allows me to access services right away. So here's my Terraform. I've got 2 examples, right? This is the traditional ingress gateway. Then there's also an app stack or a Vault stack, which is for running Kubernetes clusters, and I'll explain that at a different time. When this runs, it's going to be a little bit longer than 15 minutes, so I'm going to keep it out of this video. But when it runs, this Terraform talks to Distributed Cloud then munges it up in Terraform again and sends it at Azure in this case, right? Given my variables. Now, when that happens, it shows up under this multi-cloud network connect. So under multi-cloud network connect, and I'll make this a bit bigger. We're gonna have to log in again because I was talking for too long. So under multi-cloud network connect, I run this Terraform, it spits out 3 instances in Azure, and we should go look at that right now, right? It spits out 3 instances in Azure under a resource group that I've, let's say eloquently named Kalalang just XC, F5XC resource group. So we can see the 3 resources that got spit out, and there's master 1, 2, and 3. Remember, a 3-node cluster, each one has a public address, each one has an SLO interface, which would be considered an outside interface, a disk, right? And then there's some other stuff in here that's not entirely used yet, but it's a base for other things that we might want, which is a load balancer across the 3. That's kind of a cool idea, right? And then a scale set, which could be used in the future for making sure that like device health, right? Rebuilding. So it built out all these things. All of this shows up as one site inside Distributed Cloud. So I'm searching for my name, right? Because I'm me and I want to see all the stuff that I built. Oop, I guess I can't actually spell my name. There we go. It's going to create this. It's going to go through many stages. Right now it says online, but when Terraform first hits it, right, it's going to go provisioning, it's going to go validating, very similar to the Terraform steps, and then it's going to go provision all those things, and then it's going to wait, right, essentially until they all check in. Now, this particular site would allow me all of the resources inside, right, my Azure environment. So I landed this site, and let's go back to that picture again. I landed this new Azure site inside my Azure account, right, inside a resource group. So now anything that my Azure account has access to within that, let's say VNet or peered VNets or whatever else it is, anything that networking wise I can get to within that environment, now this CE can too. And the CE doesn't require inbound connectivity, right? It actually calls home. So when it calls home to the regional edges, it reverses the call. The regional edge now sees the customer edge, and the customer edge becomes an origin for the regional edges. And that allows me to create things like a globally available service for a privately available application. Okay, so it's created this thing on the inside. We can very quickly see the stuff that's in here. So mine's got 3 nodes in it. Those 3 nodes are all healthy, right? They're all green, they're available. If I wanted to create a service now, I could create a service that exists here that I'm going to expose someplace else. That wasn't the request from Ed. He wanted to know what day 1 and day 2 operations look like. Now, you can deploy one site with 3 instances like I did here, or you could deploy 3 sites with 1 instance instead. The benefits. If this one site with 3 instances, if say master 2, which happens to be my control data plane, goes offline, then another one of the units will elect itself as the control plane, the controller data plane. And if I'm at home asleep in the middle of the night, that sounds really appealing. Now, as I come into the next day and I have to figure out what happened, the box got corrupted, somebody pulled the plug. I mean, imagine these things could also be living in hardware land inside of a data center. Somebody pulled the plug. If I can fix the resolution by just plugging something in and turning it on, then great. It will auto fix itself and it becomes another electable controller data plane. If I can't fix it, like somebody managed to rip it out of the rack and throw it on the ground, then what happens is I would likely pave a new cluster and destroy this cluster. Now, that sounds really daunting, except for this is a new style of thinking. My configuration lives in the console. It's not tied to the infrastructure until I tell it to tie it to the infrastructure. So I can have a service, kubernetes.kalalang.net, like some of the demo ones that you've seen before. I can have a service sit on top of multiple sites, and within a site sit on top of multiple instances. So it would be easier for me to pave a new cluster, add those 3 new instances with the 2 instances that are broken, and then migrate the traffic from one cluster to another. And the service is available, and then I just deprecate the old one. It is very, very much pave and nuke, right? So pave new infrastructure, nuke the old stuff. Now, in the event that these things are running for a while, and they will, I don't expect pave and nuke, right? For everything unless it's an emergency, you can upgrade them. So if I wanted to come in and see dashboard, I guess, actually I want to be on the instance itself. If I click on the dashboard and I can see that this site is running this version of F5 software and this version of the operating system software. Now, Terraform doesn't have any knowledge, right? Remember the instance ID or the SKU for Azure was like just the name of the thing. It doesn't know what version it is because it should not be maintaining version. We don't want you to do that. So in here, if I needed to upgrade it, and you can see mine were upgraded yesterday, I would just click the upgrade button and it would one by one upgrade the individual units inside the cluster, right, by moving that controller data plane across them, allowing services to continue to work, right, without having to take any kind of outage. So for Ed's question, when and why and what would I do with the day 2 operations of problems, I would still use a 3-node cluster because now there's redundancy in the cluster. There's redundancy in that one site. If I needed to scale, I would add more clusters under the service. So I may have 3 clusters that all service one application, right? That's distributed across all of them, hence the name, right? Instead of having one cluster with 3 nodes spread across it, because I can create more aggregate bandwidth. So there's benefits for scaling this way, and then there are also benefits for scaling within the site. Meaning, if I didn't want to, at the end of the day, or worry about it in the middle of the night, if that one site was running with one instance in it, but say I had 2 sites, now I'm at 50% redundancy, right? See where I'm going with this? In the event I didn't want to do that, I would still run the 3, which I would, and then another 3. That way, if one of them failed, this is still just as powerful as it was at the beginning of the day during the outage, right? And then I have this other cluster that I can move to when I want to rebuild it, right? So there are benefits of going probably either way, but I think the 3 in a site for production level, still extremely valuable, but scale horizontally based off number of clusters for throughput or aggregation. So let's see, that was a lot of stuff to go over. Hopefully I'm still within my 15-minute window, but just a quick review again. This is creating a customer edge inside a private environment that allows me to hook that private environment and services that are in it to expose those services either locally or on the F5 regional edges at the global footprint. All of the services that I would deploy, like load balancing or origin pools, WAF, they can exist in both locations, so you can decide, right? It's the same console for both of them as well. So now I can manage infrastructure on premises and infrastructure externally. I used 2 modules. The first one was the module for setting up the customer edge, and I believe there's one in here for Azure, right? Azure. So I used this one, which goes through a bit more detail of what I actually picked. And then I also used the one for site. Let's see if I can pick it out. Virtual site state, I think, is the one for approve or delete. It could be a different one. Maybe check out the code. So again, code would exist, distributed cloud, and then under distributed cloud, it is already Terraform. This is for infrastructure. This is the one that I've been working in, and just so we can validate that one at the bottom, it's the TF params action. And in that case, I'm going to cite the kind, and then apply. So as always, if you have a question about the solution, I needed to get this one out there, one for Ed, the other, so that way I can start explaining some of the really unique things I can do on customer edges. But if you have any questions about this solution or any of the other ones, please open an issue. I'm happy to do some follow-up on those things. If any of it becomes valuable for you, I hope that's great, and I wish you all good luck.